Take a look at this sprawling web of glowing nodes. This is what modern AI development feels like for most engineering teams right now. They are drowning in chaotic multi-agent meshes, massive context limits, and elaborate orchestration nodes trying to force AI to execute complex tasks. But the manual to untangle this modern chaos already exists. It was written 37 years ago for engineers typing C code on terminals at Bell Labs. To solve the deployment problems of modern autonomous agents, we have to look past the buzzwords of 2026 and return to strict foundational engineering principles. In 2025, companies like Anthropic and OpenAI shipped highly capable models that performed beautifully internally, yet external enterprise teams repeatedly failed to deploy them. The commercial solutions were simply too convoluted for standard engineering teams to adopt. This adoption gap created an entire industry of complexity as a service. AI companies effectively outsourced their change management, partnering with massive consulting firms to explain and implement the very tools they had just built. NVIDIA took the exact opposite approach with NemoClaw. Rather than adding consulting intermediaries, they wrapped their open models in simple YAML-based constraints and local-first compute. They trusted developers to apply sound engineering practices, and the data backs up NVIDIA's bet. Research from Factory.ai consistently reveals that when an enterprise AI system fails, the agent itself is rarely the broken component. Multi-million-dollar agent deployments fail because the codebase environments they operate in are messy and unstructured. The models have the capability, they lack a clean space to work. Enter Rob Pike. He co-created the Unix operating system and the Go programming language. In 1989, he wrote down 5 rules for programming. Today, those rules map perfectly to the exact bottlenecks choking AI agent deployments. Notice how this unstructured block of data loses essential pieces as it shrinks under pressure. This illustrates our first major hurdle, context compression. Long-running AI sessions fill up their working memory limits. When standard algorithms compress that memory, they silently drop critical project milestones and intentions. Now watch what happens when we apply Pike's 5th rule. Data dominates. By enforcing a rigid, structured format for the agent session state, explicit sections for decisions and next steps, the compression algorithm is forced to preserve the elements that matter. The structure dictates the survival of the information. The second major hurdle is codebase instrumentation. Engineering teams regularly complain about poor AI output, so they swap models or rewrite prompts based purely on vibes. They make these changes without ever establishing a quantitative metric for what a good response actually looks like. Pike's 2nd rule provides the fix. Measure first. Before tuning an agent, teams must build golden test sets and evals, domain-specific automated guardrails that verify what an agent should and should not do in your specific environment. In agentic systems, the raw capability of the algorithm is secondary. Success is dictated entirely by how well you structure your data and how strictly you measure your baselines. Watch this perfectly aligned wall break apart. This is what happens to code generated by AI without strict oversight. Agents are eager but lazy developers. Without strict linting, which is the automated checking of code for stylistic and programming errors, their output naturally drifts toward entropy, leaving you with complex, unmaintainable code. Pike's 4th rule is, simple is less buggy. By putting agents in a static analysis straitjacket, you physically prevent them from generating unchecked complexity. The code must adhere to best practices at all times. Then there is the obsession with multi-agent meshes. Teams try to build elaborate fleets of agents coordinating with each other before they can even measure if a single agent works. Pike's 1st and 3rd rules warn against optimizing prematurely. You don't build a fleet until you prove one unit can do the job. The final hurdle is specification fatigue. Writing precise instructions is tedious work. Developers try to take shortcuts by dumping entire libraries of raw text into the AI's context window, hoping the model will figure out the requirements on its own. This brings us back to Pike's 5th rule: write dumb code, have smart objects. In 2026, that translates to building incredibly simple agents, but controlling them with rigid, highly organized specifications. So how do you actually build an enterprise-grade agent system from scratch tomorrow morning? You follow a strict, additive 5-phase framework. Phase 1 is foundation. Fix your codebase environment, clean up your documentation, and set your linting rules before you even touch an AI model. Phase 2 is simplicity. Give one agent one job, and tightly limit its blast radius, meaning you restrict its permissions to contain the potential damage of any errors. Phase 3 is measurement. Establish your baselines using those golden test sets. Phase 4 is data structures. Stop dumping raw text into prompts and start building clean context hierarchies that the agent can easily navigate. Finally, Phase 5 is scale. You only introduce multi-agent orchestration when your single-agent metrics prove you have hit a hard bottleneck. Look at this matrix. It maps Pike's original 1989 rules directly to their modern agentic translations. These principles function as daily operational constraints, turning theoretical wisdom into a production-ready checklist. Safely scaling AI is not about buying an expensive new orchestration node. It is a pure test of your foundational engineering discipline. Technology hype cycles follow a predictable pattern. The market constantly pushes novelty and complexity because, frankly, complexity generates massive consulting revenue. But the engineering teams that are actually succeeding with AI out in the real world all converge on the exact same ancient wisdom. Keep your systems simple. Measure relentlessly before optimizing, and get your data structures right. The AI agent itself is never the hard part. The real work lies in your environment and your specifications. You do not need a multi-million-dollar consulting firm to figure that out, because Rob Pike handed us the playbook 37 years ago.